Hi, my name is Dr. Kazmaier and I work at the UK Data Service and the Cathy Marsh Institute. I teach and research on computational social science, which is the use of computer science and big or novel data for social science research. For example, if social scientists want to understand how work commutes have changed post-COVID-19, they could run surveys asking people how they used to commute, how they commute now, why they've changed. But computational social scientists could use available data to establish pre-pandemic commute baseline and current commute patterns and to model the changes in conditions and decision making. To make sure people understand the conclusions, the research project should be both open and reproducible, which requires a clear process. Today, I want to tell you about the computational social scientist skills and a 10-step process to move from vague research question to reproducible research project. First, let's talk skills. Trained social scientists already have a good set of applicable skills and experience, but computational social scientists need to add on skills related to understanding and documenting computer science methods. To this end, social scientists can use a 10-step process to move from research question to research project. Now, I'll quickly run through those 10 steps, explaining them using the example I mentioned earlier about commutes. So first, identify the problem or the question. So I want to know, how do people commute post-COVID-19? Work from home, public or private, active or passive? I also want to know why. Then identify the scope of the system in which this question will apply. So I'll narrow it down to 2 or 3 regions within the UK. I will only address work commutes, and I will limit my span of time from 2011 to 2021. I then need to conceptualize the system. So I establish baseline commute patterns from census journey to work data and identify changes from data scraped or collected from websites and APIs. I also want to incorporate things like road patterns, bus routes, tram lines, all of this kind of stuff, and the cost of different, transport options as well. Then I will formalize my hypotheses in either pseudocode or flowcharts or mathematical models. So I want to clarify that when public transport prices go up or down, what I expect to be the response seen in commuting behavior, for example. Then I'm going to build a software implementation. For me, that would be an agent-based model written in NetLogo. Then I'll verify my software implementation, which is basic parameter sweeps and testing to ensure that it matches my formalization. Do I see the changes I expect when the bus fares go up or down? Then I run a set of experiments in which I establish the range of possible future scenarios for the 2021 census journey to work data under varying conditions. What if bus fares are high? What if the social distancing law goes back to 2 meters? What if parking in the city centres is no longer available? All of these different conditions. Then I will analyze which scenarios are most likely under the different conditions or different combinations of conditions. Validate my results by comparing to the 2021 census journey to work data when it becomes available, and also by making my code and data available for peer researchers to use. Finally, I will argue for policy changes to implement the conditions that it seems are most linked to positive outcomes. So what are my conclusions? Basically, that social science research benefits from computational methods. It does not replace classic social science research, but it elaborates and supports. For example, you can collect much more data and do it much faster using computational methods than traditional surveys. It's also different data. It's fine. It's allowed to be different. Reproducibility is greater, especially when you share your code and your data. It supports open and collaborative research, better understanding, peer validation. Exploration is really great. Computers can run millions of experiments under exploring millions of possible conditions, including counterfactual conditions, like if we banned all cars or if, we all commuted to work by helicopter. Analysis More data equals more chance to identify links between variables, outcomes, and scenarios that we can then explore in other ways through other research methods. And my personal favorite, clarity of modeling or representation. If you can formalize your hypothesis and thinking in software, it forcibly removes vagueness. And if you can get a computer to understand it, you can get people to understand it, because computers are thick as two short planks. Thank you very much.